Hello, my amazing students. This is Mrs. A, and we're doing 6.1 tonight. So we're talking about simultaneous solving of equations, and this is the first one that's on the back of your PowerPoint slides. So I'm going to do these problems with you tonight to make sure that you know how to do them. So the first one is a graphing, how to solve by graphing. So we're going to graph these two equations. Now when I start to graph one like this, I like to use the intercepts, the x and y intercepts, because you know that if I cover the x up, I can see that y needs to be negative 15. So negative x is 0, so 0, negative 15 is a solution point. And it is also on the y-axis. So 0, negative, oops, that's going to be way far down there. I need to adjust my graph. I tell you what, we're going to count by threes on this graph because you see I don't have enough to go down. So we're going to make each hack mark 3 so that we get a fairly accurate graph. So if we're going down 15, we're going to go 3, 6, 9, 12, 15. So that will be down 15 and we will adjust. So this is 3, 6, 9, 12, 15 and 3, 6, 9, 12, negative 15. So we're just going to adjust our graph so that we know that we're counting by threes. Anytime you adjust your graph, make sure you make a note of it so that your teacher knows you adjusted your graph. Okay, so then we're going to let y be 0. If we let y be 0, we cover it up, then we get 3x is negative 15, which means that x is negative 5. So negative 5, 0 is a point. Okay, so we're counting by threes, so negative 5 is going to be not quite to the second one. So we'll put a point right there. Okay, so we're graphing this one and it's going up through here in this direction. Okay, and then we're going to graph this one, which is going to, if I let x be 0, then y is 9. And so it's a slope of 3, y-intercept of 9, 3, 6, 9, okay, and then it's got a slope of 3. So that's going to be up 3 over 1, up 3 over 1, and that's kind of hard to do. So let's just find the point. Let's go backwards here. If we plug in a negative 1, then we're going to get a 6. If we plug in a negative 3, we're going to get a 9. So negative 3 is just one little hack mark there. So this one's going to come down this direction. Okay, so I've got something that's looking like that. All right, so now I'm going to look at the graphs that they give me over here on the screen. Okay, so first let's look at ours. We are crossing the x-axis at 0, negative 15, and negative 5, 0 on one of the lines. So now let's go. And we have a line, we're looking for a line that's crossing at 0, negative 15, and also at negative 5, 0. So if that's the same line that's got to cross at 0, negative 15, and negative 5, 0. So it's going to have to be something that's going through negative 5, 0. Well, this one does not go through negative 5, 0. And this one does not go through negative 5, 0. And this one does look to go through negative 5, 0. So that's one option. And then this one looks like it goes through negative 5, 0. But the other end of it does not go through 0, negative 15. So the answer should be C. And we can see in C that it looks like it's intersecting somewhere in this, remember, 1, 2, 3, the third quadrant. And I look at my graph, it looks like it's going to be intersecting somewhere down here also. So The answer is going to be C. It is the closest to our graph. And the answer is C. All right, so the next problem, number 2 in the back of the book, is looking at these two equations. So I have a 3x minus y is equal to 7, and negative 6x plus 2y is equal to negative 14. Okay, so when I do these problems, I know that the slope of the line, remember I showed you in class that if we took ax plus by equals c, the standard form of the equation, and we solved it for y, we would see some really cool things pop out. So I'm going to solve for y. So I get by is negative, because he's moving over there, negative ax plus c. And then I divide by b, and I divide by b, and I divide by b. And I now have a 1 here, so I'm going to go ahead and just take that off. So I get y is negative a over b x plus c over b. But I know that I have just put it in y is mx plus b form. So this m right here is always going to be negative a over b whenever I have my equation in standard form, in slope-intercept form. So slope-intercept form, I start in standard form, and that's where I get the a and the b. But when it turns into slope-intercept form, negative a over b becomes the slope. So m is negative a over b when I start in standard form, and I get my a and my b and my c. Then negative a over b is always my slope, and c over b is always my y-intercept. And that's really cool, because then we can look at an equation. We say, okay, it's in standard form, so negative 3 over negative 1 is the slope of the first line. And since it's negative a over b, then it's going to be positive 6 over 2. And look at those two slopes. If I simplify them, aren't they both going to be equal to 3? So these two lines have the same slope. But not only that, c over b is the y-intercept. So 7 over negative 1 is the y-intercept of the first line. So 7 over negative 1. And then the second line's y-intercept, c over b, is negative 14 over 2. What happens to those two y-intercepts? Do they look like they're equal to each other? Negative 7 over 1, negative 7 over 1. Okay, or negative 7. They're both equal to negative 7. Therefore, we have two lines that actually have the same slope and the same y-intercept. Therefore, they are the same line. So what we're going to look for is we don't have to graph both lines. They are the same line. And when we look at this one, we already know it's got a y-intercept of negative 7 and a slope of 3. So which one of these has a y-intercept of negative 7 and a slope of 3 and looks like it's the same line? Now, A is definitely not the same line, and D is definitely not the same line. Now this one up here, B, if you look real closely to it, it's actually two lines very close together. Okay, but this one right here is one line, and when we look at it, we've got negative 7 as the y-intercept and a slope of up 3 over 1, up 3 over 1. So the answer is C. All right, this one is going to be tough because it tells us to solve it graphically, and I do not have very good graphing situation here. So I'm going to go to something else that gives me a better graphing situation. Okay, so the first equation is 2x plus y is 9. So if I plug in a 0 for the x, I'm going to have to get out a y is 9. So 0, 9 is a point. Okay, if I plug in a 1 for the x, then I'm going to get out a 2 plus something is 9, so I'm going to get out a 7. If I plug in a 2 for the x, then I'm going to come up with a 4 plus something is 9. 4 plus something is 9, and that will be a 5. Okay, so 0, 9, 1, 7, 2, 5 are going to be some points that are going to fit into the first line. So you're now getting a picture of me taking a picture of me, but these are the 3 points, 0, 9, 1, 7, and 2, 5. So let's plug in 0, 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's put a point there. Okay, and then 1, 7, 1, and then 1, 2, 3, 4, 5, 6, 7, and then 2, 5. So 1, 2, 1, 2, 3, 4, 5. Now I can come over here with this graphing tool and I can get a straight line. And then I can go through those points and continue on a straight line. So this is a slope of -2, isn't it? All right, so there's the line. I can make it go up that way too, at a slope of 2. And that's a pretty decent line. Okay, so now let's look at the second line and plot some points. Okay, so the second line is x is equal to -2y. So when we plug in for y a 0, we get a 0. So this line goes through 0, 0. Okay, so this line goes through 0, 0. And then if I plug in a 1 here, I'm going to get a -2 out here. So that's going to be a 1 for the y and a -2 for the x. This thing's not very easy to work with. Okay, so let's get one more point. What if I plug in a -2 for the y? If I plug in a -2 for the y, then won't I get a +4 for the x? So now let's graph these 3 points into, we'll make this a red line. Okay, so let's make this one red. And we got a 4 and a -2. 1, 2, 3, 4, down 2. And a 0, 0. And a -2, 1. Okay, so now let's get a line and let's graph through those points. So this has got a slope of -1/2. Okay. And about that. Okay. So now let's extend our blue line just a little bit. We were going down at a slope of -2. So let's see if we can move this thing a little bit, because I think I probably ran off the track a little bit there. So it's going down 2 over 1, down 2 over 1, down 2 over 1, down 2. There we go. Okay, so let's keep on going at that slope and try to get it right at the down 2 over 1 slope. I think I've got off of it here. Trying to go through there. All right, so that's pretty close. Now, about where do you think we intersected? Okay, so this is a difficult method, but about where do we intersect here? So right about here, which looks like it's about what? 1, 2, 3, 4, 5, 6, maybe 6, negative 3. Okay, now, the 6, negative 3 will work for the second one. Let's see if 6, negative 3 will work for the first one. The first line was 2x plus y is 9. And we're trying to check and see if this is a good guess. So if I plug in 2 times 6, I get a 12. Minus a 3 is a 9. Well, that was a good guess, wasn't it? And then the other equation, remember, is x is equal to negative 2y. Oops, sorry about that. And then if I plug in my x is 6 and I plug in a negative 3 here, then I do get negative 2 times negative 3 is 6. So this is a good guess for the and it has been verified that that is the intersection of the two lines, which is the solution to the system. Okay, so now we're going to try to do the next problem on the PowerPoint slides, which is 3x plus 4y is 7, 5x minus 2y is negative 23. So we're going to use the, I'm going to use the ABC method, which basically I'm just made that up. The slope, remember I just told you that the slope of the first line is going to be negative a over b when the line is in standard form, okay? And when I look up here to the first line, the a is a 3 and the b is a 4. And so that's going to be negative 3/4 is the first line slope. So negative 3/4 is the slope of the first line. And the y-intercept of the first line is c over b, which is 7 over 4. So the y-intercept is 7 over 4. Okay, so that's the first line. The second line is 5x minus 2y is negative 23, and its slope is going to be negative a, which is negative 5, over b, which is negative 2. That is going to simplify to 5/2. And its y-intercept is going to be negative 23 over negative 2, or 23/2. So let's use this information. So the first line we will make blue, and it has a slope of negative 3/4 and a y-intercept of 7/4. So let's start over here, and let's make 7/4 is going to be, we're going to make each one of these a fourth. Okay, this will be easy since we have 7/4 and 3/4. So we're going to make this one, and then this one is going to be 7/4 right there, because it's 7 steps up. 1, 2, 3, 4, 5, 6, 7. But each one of those steps is a fourth. And then I'm going to have a slope of negative 3/4. Okay, so I'm going to go down 3 and over 4. Now that should work with, even if I'm going, because if I was going down 3/4 over 1, down 3/4 over 1, it should wind up being the same thing. So this should be my slope, And then I'm going to grab a line, and I'm going to go, so this one, basically I'm doing a fourth in each direction, so that should work. Each one of them is a fourth no matter which direction I'm going in. So down 3 over 4 and down 3 over 4. That looks like that's about right. Let's extend it a little more. Down 3 over 4. Okay, so now let's do our second line in red. And we have a slope of 5 halves, but we've got to go all the way to 23 halves. Okay, so 23 halves, since each one of these was going to be 46. Oops, I forgot to put that back in there. It's going to be 46 fourths. Wow, so I have to go way up. 46 fourths way up there. So that's going to be hard for me to graph with the y-intercept. So I'm going to have to start the line a little bit farther down. So let's just plug in a point to this second line. Since I can't get the y-intercept, it's way up there. Let's go ahead and plug in some points that are closer to home here. So let's plug in something like 0. Okay, so let's plug in a 0. And then if we plug in a 0 for the x, then we're going to come up with a what for the, well, we already know what the y-intercept is. It's way too high for us. Let's plug in a 0 for the y. How about we do that? If we plug in a 0 for the y, then we're going to have what for the x to get to negative 23. So we're going to end up having x, 5x is going to be negative 23 fifths. So negative 23 fifths is the x-intercept. Okay, so that's not going to be easy because each one of those, that's going to be negative 4 3/5, and that's not going to be easy to graph either. But this is negative 1 and negative 2, negative 3. So basically I have to go 1, 2, 3, 4. That's a 1. 1, 2, 3, 4. That's a 2. 1, 2, 3, 4. That's a 3. 1, 2, 3, 4. That's a 4. And I've got to have 3/5 more. So we'll put it about there, although that's not quite accurate. Okay, because everything's in fourths. It's a little hard. So let's get a point over here closer to where we're going, because we know that this line, this blue line, continues on, and our y-intercept is this over this, so this positive. So we're going to have a really big one over there. So our line is going to intersect. Oopsie. Let's try to do this. Our line is going to intersect way over this way, right? Because we were going down 4, and then we're going to go up 3 over 4, up 3 over 4, up 3 over 4. So our intersection is going to go way off in that direction. This is not a very friendly one to do by graphing, okay? Because it's got really weird points, and that does not look like a straight line. But we're going to pretend it is right now. We're going to just get close, and then we're going to solve this one using another method. But can you see that since this y-intercept is way up here somewhere, and this line goes this way, and this other one has a point way over here, that this red line is going to have to go somewhere up here and intersect way up there somewhere with this blue line. Okay, so this one is not a very friendly one to do by graphing. So we'll just use a different method to solve this one. And then, because this one is just not fitting on my screen very well. So let's go ahead and use elimination. So we can use elimination with this. 3x plus 4y is equal to 7. And Now, this second line, I'm going to multiply the whole thing by 2. And when I do, because I'm using elimination, I'm going to get 10x. Okay, and then minus 4y, which is going to cancel with the 4y above it. And then 2 times the negative 23 is going to be negative 46. Okay, so now when I add them together, I get 13x is equal to a negative 39, which means that x is equal to a negative 3. Okay, so x is equal to a negative 3. Now remember, this is 1, 2, 3. So we said it was x was equal to way up here somewhere. But then let's find out what the y is. If we plug in right here, x is negative 3, right here, then we get negative 9 plus something is 7. Okay, so then I'm going to add the 9 to this side, and I get 4y is 16, or y is 4. Okay, well that was not hard to solve using elimination. So negative 3, 1, 2, 3, up. Okay, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Oh, we're too far dead. So 1, 2. I need 2 more steps and I don't have them. So the solution is about there. And we came close with our very fuzzy drawing, but my drawing, I made a bad decision to start with by putting the grid in fourths. I should have started with putting the grid maybe in by 2s, and that would have been a better decision. But I didn't. So the graph did not go up high enough, and so negative 3, 4, when we're counting by 4s, will be about here, and that's a good answer. So this one we found by, not by graphing, but by elimination, because our grid went off the board. Okay, so here are 2 problems that they tell us to use to solve by substitution method, and I'm going to do those for you on the board, or at least one of them. All right, when we're doing substitution, we always want to get one variable by itself. So when I look at my system, I only have one variable that really yields itself to solving by substitution. So I'm going to solve for that x, and I'm going to say x equals, and I'm going to move the negative 4, the 4y comes over here, and I get 23 minus 4y. So now I have a sub, and I'm going to let this be my core equation, and then I'm going to let this one be the substitute. So I've rewritten this one into another form that I can put into my equation. Okay, let me get this a little straighter here. Okay, so now I'm going to rewrite the core, but I'm going to leave a space where the x is. So 9, there's my space where the x is, plus 4y is equal to negative 17. So now what I'm going to do is I'm going to take this x and I'm going to sub it in where the x is supposed to be, but I'm going to use this instead. 23 minus 4y. Okay, so now I have one equation in one unknown. Okay, and that's kind of a big number, but what is going to happen when I solve this? I'm going to get another board. All right, so I went ahead and did the math for you, but we have this equation was the last one I showed you. And then I distributed the 9 through here and got 207 minus 36y. And then plus the 4y is the negative 17. The negative 36y and the 4y gives you negative 32y. And then the negative 17, I brought the 207 around to make it a negative 207 on that side. And then I ended up with negative 32, y is negative 224, or y is 7. I'm not done. I've only found one of the two coordinates. So now I'm going to take the y is 7, and I'm going to go back into this equation. So if y is 7, then I can put the 7 right here and plug it in there, and I'll get 23 take away 28, and that's going to be x is negative 5. Okay, so that is the answer. Y is 7, x is negative 5, and the point is negative 5, 7. So our intersection point is negative 5, 7. And we already checked it in one, so wouldn't it be smart, since we checked it in this one, wouldn't it be smart to go back to this one and check is, so y is 7, is this point going to solve here too? So 9 times a negative 5 is a negative 45 plus a 28. So negative 45 plus a 28, is that equal to a negative 17? Let me look at it a minute, and it is, right? Because 7 and 8 is 15. So we did get the right answer, which was negative 5, 7.